For each of 5 through 21, prove each statement that is true and find a counterexample for each statement that is false. Assume all sets are subsets of a universal set U. For all sets A, B, and C, A union B minus C equals A union B minus A union C. So let's see if this makes sense on a Venn diagram. Now, the left side is a combination of two sets. We have the set A, which is over here, and we're going to combine the set A with B minus C. So we're going to combine this with everything that's in B and not in C. And the only region that we haven't colored in yet that is in B and not in C is this region as well here. So this is the left-hand side. Now let's do the right-hand side. We can imagine A union B, which is the combination or the union of A and B. And then we need to subtract everything that's in A union C. So we want to remove everything that's in the combination of A union C. So that's everything in here. Now, if we were to remove this region, then the only region left would be this region in B that's not in A or C. And so this is what the right-hand side looks like. Now, as you can see visually, these are two different sets. Now, we have to ask ourselves, what's different about these sets? In the first set, there are elements in A, but in the second set, there are not elements in A. So long as we ensure that A is not the empty set, we should be able to prove that this is false with a counterexample. Now, so long as we have elements in A, we should be able to prove this to be false. So B and C really shouldn't matter. We can set B and C to be anything. So I'll just pick like 1 and 2, and then C could be 3 and 4. But again, it really doesn't matter here. What matters is that A is not empty. Now let's evaluate the left-hand side and the right-hand side separately. We could first start with B minus C. B minus C is everything in B that's not in C, which is just everything in B. And then if we combine that with A, we just get the set B, which is 1 and 2. Now let's do the right-hand side. We'll start with A union B, which is just the set B, 1 and 2. And then we have to calculate A union C, which is everything in A or C. That's the combination of A and C here, which is 1, 3, and 4. And then we have to take this set and subtract that set. So A union B minus A union C is just the set containing 2. And the key here is that these two sets are not the same sets, which means that this A, B, and C is a counterexample to number 13. Thanks, everyone, and I'll see you in the next video.